Welcome, friends, to Science Talk. I am your host and resident oceanographer, Jim Massa.
All right, well, good evening, everyone, and welcome to Environmental Coffee House. I am your host, as always, Sandy Schoelles, and I'm here with Jim tonight. And we have, oh boy, we have a lot to talk about. Of course, AMOC is in the news again, and we are losing the ability to intake the carbon from the atmosphere. We have flooding all over the world. We have just a plethora of issues, and we're going to talk about them tonight. What's floating and tipping around, Jim? How are you?
Hello, Sandy. Hello, everyone. Welcome. Uh, well, yep, AMOC's back in the news. Well, I
Oh,
don't know if
yeah.
they ever left, but
Right.
it's back in there. Um, Definitely of concern what's going on there. That's for sure.
Oh, absolutely. Absolutely. But tonight, I mean, I have a couple of videos. Of course, we're going to show a little video I put together of the daddy of them all, Wally Broecker, our favorite. And we're gonna do that. We have slides. We have another video of Ramsdorf. We're going to get into it. And Jim is going to talk about, again, for those of you that might be new, you'll learn what you may have not known before about the oceans and AMOC. And we also are going to talk about the loss of research with Russian scientists, and then whatever else comes up that we feel like talking about with you all. So, welcome, and I'm glad you're all here. So, Jim, have you got a starting message?
Oh, well, let's see. AMOC is definitely slowing down. We've been measuring this for decades. Um, you hear a lot of collapse, tipping point. You hear a lot of those terms being tossed around.
Hmm.
And the question that I raise is what constitutes a collapse? Do they mean full stoppage of AMOC, meaning that there's absolutely no more deep water forming at all, no more sinking at all? Do they, when they refer to tipping point to what? A full stoppage or a reduction in deep water formation to the point of that the North Atlantic deep water return flow doesn't really happen. So these terms need to be better defined as to what is meant. Now, if you're talking about a tipping point to the point where the slowdown is significant, then you need to define what constitutes a significant slowdown to really cause more problems. I mean, right now, there's there's some unsettled weather, shall we say, for the last couple of years in the North Atlantic. I mean, I have friends
Uh-huh.
in Sweden who, northern Sweden, but they're now been getting snow in June. And we're not talking about little
Oh,
flurries. We're,
lovely.
we're talking about we're talking about several inches or so or more that accumulates and sticks around for several days.
Mm,
So we're definitely seeing a cooling down in certain locations in the North Atlantic. Places like the Scandinavian countries, Iceland, well, I guess part of that too, but the UK, the, they're going to kind of you know get cooler than normal conditions, and that of course is due to you know you have the cooler sea surface temperatures there, and you therefore any atmospheric movement will pick up the cooler temperatures from the water and affect what happens. You have the positioning of the North Atlantic oscillation and the Arctic oscillation changing about that going to affect wind patterns and hence precipitation
yeah.
patterns. So there's a lot that's already happening now. And I guess later on we'll get into it. And Stefan Ramsdorff's video there,
Mm-hmm.
he talked about changes in precipitation patterns. And yeah, because if you're not going to efficiently transport the heat from lower latitudes to higher latitude, you're going to change the heat gradient and the pressure gradient. And this in turn affects, the Hadley cells, the Ferrel cells, and so forth, that precipitation patterns then get changed about. And on the flip side, if the northern hemisphere cools down, although I still maintain that unlike in the past, it will just be regional, no, not hemispheric cooling,
Mm-hmm.
but the southern hemisphere warms up,
Yeah.
and also the ITCZ changes its location, which affects precipitation patterns,
Give us
air
the
temperature,
ITCZ
the
definition.
intertropical convergence zone,
Okay. Remember, there's some newbies here.
and that's in the Pacific.
Yes.
Usually straddles the equatorial region. So that's been shown to change positioning with changes in overall global temperature patterns.
Mm-hmm.
So there's a lot that there's a lot of implications from a significant slowdown
Yeah.
in AMOC or a complete stoppage of AMOC.
Mm. It's scary. But even here, it's been I trend the temperatures. I chart them from year to year and I look back and we've been in the 70s. I mean, it's October. It's in Western New York. It's not supposed to be 75. It's not supposed to be like that. And then I looked at some of my stuff, when Facebook pops up with your memories, and then I see, oh, look, I was bitching about the same thing 2 years ago, 3 years ago. It's every year, it stays warmer longer. And a lot of people are, oh, we're so happy. It's warm. We can wear shorts, not understanding that it is not a good thing. Not a good thing that it's 75 degrees at the end of October. Nope. So I mean it's all
Well,
over.
you take, for example, okay, this past week we had pretty nasty storm hit interior Alaska, and it was snow, it was rain, it was sleet, it was just snotty,
Ooh.
and temperatures were right around freezing, and this crap was just coming down. And here it is October, we're having temperatures near freezing. Usually October is about 0, -10, you know, and it's just snow, light
Right?
fluffy snow, not the
Fluffy
wet heavy,
so.
lake effect snow that we basically got here.
Somebody asked what AMOC is. She's a newbie. It's a friend of mine, and I just put it up. I put it up. Atlantic meridional overturning circulation. So just so you know, she's new and she's learning. Hello, Luann.
Mer- Meridional refers
Yeah.
to longitude, so
Mm-hmm.
you know, overturning in the longitudinal directions.
And we'll be showing you the graphs so you'll be able to look. So, what I thought we would start out with was the daddy of them all, Wally Broecker, because he Well, you tell us who he was, and then I'll play the video. But he really was the daddy of all of this ocean physics and what's been happening
Well,
now.
Wally Broecker has often called the grandfather of climate science. He developed a lot of the techniques that are still in use today. Obviously refined over the years, but the basic ideas are still in use.
Hmm.
Namely, the use of radionuclides to trace water movement in the ocean, as well as identify water masses in the oceans. The use of isotopic fractionation to recreate or you know paint the picture what the climate was in the past, to even use it to
Yeah.
uh, ascertain when the conveyor belt is running or not. you know so using, for example, the fractionation of C13 and C12, uh, using the fractionation of O18, O16 to inform us when there are large ice sheets on the growing on the continent, or when they were melting away. So he developed a lot of techniques. There's a lot more that he did. I mean, we can spend hours talking about
About Wally.
his
Yeah.
his accomplishments, but
Yes.
he he basically demonstrated a lot of things, and some of his work also involved AMOC, where he identified AMOC, and he also showed that it can shut down and start up again within a matter of decades.
Well, let's go. Let's play his video. It's from 2009. It was an interview I found from a New Jersey. He was in New Jersey at the time, and here we go.
The so-called conveyor belt of global ocean circulation is one important concept he put on the map, but it's just part of the picture.
At first, we were curious. We wanted to know, why was there an ice age, and what's it trying to tell us? But as time passed and we learned more and more about climate, it became clear that there was something else that we could learn.
He developed two separate lines of research that came together in a powerful way, revealing much of what's known today about how carbon cycles through the atmosphere and oceans, and about the complex interplay between these mechanisms and climate.
I was using radiocarbon in the ocean to say something about the time scale of large-scale mixing in the ocean. So in a sense, I was doing physical oceanography. But I was also studying paleoclimate, using, again, radiocarbon as a way to get ages of things and correlate events in one part of the world with events in another part of the world.
Ice cores enabled measurements from past glacial and interglacial times, which showed atmospheric carbon and average global temperatures rising and falling in lockstep. Even before this was firmly established, Broecker asserted that fossil fuel use would force global warming.
I got an award in Rome, and the person that introduced me said that my greatest accomplishment was being the first one to use the term global warming. And that sort of stunned me, because I didn't realize, number one, that I was the first, and I hoped that that wasn't why people remembered me. It annoyed me because I've written something like 480 scientific papers, and if I'm remembered for 2 words that I happen to use in a title of a paper, that would be awful, a wasted career.
Wally Broecker had been studying Ice Age climate change when he wondered, at the tail end of a cool spell in the mid-1970s, why there wasn't clearer evidence that fossil fuel use was contributing to global warming.
The base of this is that CO2 intercepts outgoing Earth light. That's basic physics. And that tends to create a thermal blanket, and it will warm the Earth, there is no doubt.
Since then, observations have shown a warming trend, and ever more realistic computer simulations project more of the same, even under conservative scenarios. Predicted changes, such as accelerating sea level rise, melting ice, and increases in both drought and flooding rainfall, appear to be ahead of schedule. Broecker's main tool for understanding where things are heading is geochemical analysis of the past.
The work I'm doing now, I'm looking at evidence for changes in past rainfall distribution on the planet. I sort of have the idea that one of the things that's going to have the biggest impact is a change in the distribution of moisture, especially in the drylands and on the earth.
Outside the lab, he says, awareness has turned into action.
Now I'm sort of a man that spends part of my time trying to convince the world that there are things that we ought to do to get ourselves ready to deal with the problem. I'm concerned that no matter what we do, we're going to at least get to double CO2 content over what we had in 1800 before we started the Industrial Revolution.
He says measures beyond conservation and existing technologies for renewable energy are needed, such as capturing carbon dioxide from power plants or simply from the air and storing it in the earth. In New Jersey, as elsewhere, projects related to carbon capture tend to be small-scale and very early in the R&D cycle. That's the kind of work Broecker would like to see expanded and accelerated.
We've wasted 30 years since we really knew this was a problem, doing almost nothing along these lines. Maybe it will be wrong, and we'll luck out. But to do anything takes an enormous effort. And so it isn't as if we can wait until we know what's going to happen and then turn a switch. If we're going to do something, it's going to be 50 years of really hard work.
Now, that was in 2009. And of course, what is the saying? Faster than previously expected? Oh, yeah. Oh, yeah. But he was the guy.
He was. And he worked until literally the last seconds of his life.
Yeah,
They found him slumped over. They found him slumped over at his desk at Lamont Doherty in Columbia.
So sad. 19. He died in 2019. And actually, Sam Mitchell, Collapse Chronicles, did the last interview with him. The last one. Yep. And yeah, but I wanted to start with him because really, you know, the granddaddy of AMOC and the ocean physics that he talked about, that you and I have done many shows on, and we will continue because it's a very pertinent topic. And the scientists there that are the Arctic scientists, many scientists have written that letter to the Arctic Council, and I would say they're freaking out a bit, wouldn't you?
I don't know if they're writing a letter, let's just say they have high levels of concern.
Mm-hmm. Yeah, really high levels of concern, very high levels of concern. But then again, you know, AMOC, when there's a new study, as we've always done the shows, whenever there's a new study, we do a show on AMOC. But this time, it just feels a little different, you know? Just feels more foreboding, Jim. But so many things do. I mean, we've seen, and directly from what Wally was saying, the precipitation around the world, we are seeing the torrential rainstorms in Middle Eastern countries that we've never seen before, which is not weather modification. So if anybody says it, and it's just, we've been seeing all this stuff now, and it is disconcerting. Anybody that's on X, which we really would like to leave and get on Blue Sky, but anybody that's on X can follow Volcaholic. I didn't pull any up, but I think she's in the UK. She puts everything that's happening, all of the videos of the rains, the everything, everything. I don't know how she does it, but she is amazing. So if you want to get on X and you want to see what the hell's going on all over the world, Volcaholic. That's the person to follow. Let's hope that Blue Sky will give us the ability to have the videos like that so we can get the hell off Elon Musk's place.
Well, there's something I kind of just want to make like a parallel. Earlier, I guess like last year or so, we were talking about BOEs, blue ocean events. And everyone's like, oh, we're going to have a blue ocean event. It's going to be a disaster, da 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 da. And of course, there's the difference like, well, what defines a BOE? Is
Hmm.
it absolutely zero sea ice everywhere in the
No.
Arctic Ocean, or is it less than or equal to 1 million square kilometers?
Right.
I'm of the less than or equal to 1 million
Right.
square
Yep.
kilometer camp. But everyone's focusing on that. It's like we should be focusing on the fact that we're losing the Arctic ice. That's
Right.
what we should be focusing on,
Right.
not whether we reach a whatever level. You
Right.
know,
Yeah.
we should be focusing on the fact that the ice is disappearing, the multi-year ice is disappearing, the extent is shrinking, the volume is
Hmm.
shrinking, it melts earlier, freezes later in the year,
Yep.
the open water period is long in the year. That's what we should be focusing on and all the ramifications that brings. Well, the same thing with AMOC. It's slowing down. There is no doubt it's slowing down. Everyone's now focusing on, is it going to collapse? Well, define collapse.
Right.
What when
Right.
they use the word collapse, what are they talking about? Are they talking about a complete full stoppage? That's how I would define it, to be honest.
Okay.
Or are they talking about does collapse mean a significant slowdown? Well, then you need to, if you're going to go with that approach, then you need to define what is meant by a significant slowdown. In that case, provide numbers. How many sphere drops, how many cubic meters, whatever is for a sink rate
Hmm.
is
Hmm.
considered you're going to have to define that. And it's the same thing with
Right.
the tipping point. Okay. It's going to reach a tipping point. What do you mean by a tipping point? Again, is it a full stoppage or is it a significant slowdown? And again, I'm repeating myself, but it comes down, you need to define that.
Right.
You have to, when you start saying things like that, you need to define the parameters. It makes it easier for the general public to understand, to be quite
Well,
honest.
and you try and you're doing it on your channel and you do some really good videos, which I am going to be showing Jim's channel in a little bit. But we do want to move on because Jim's going to do, he has a little slide presentation. So I think we're going to start there. And, we originally were just going to shoot the shit tonight. But we can never just do that without slides. So the first thing I wanted to show was the graphic of Wally's because it goes with what he said, which illustrates how he just predicted exactly what's happening. Exactly. Up,
Yeah,
up, up.
and if you look at the data points there, um, without having the exact values, but it either fits a polynomial or an exponential function. Looking at towards the predicted points on the right side, it looks more exponential, but still we need the actual data point, run the curvilinear regression analysis and so forth. But it's definitely not linear. you know,
No.
that's the take home message of that. So, but yeah, he pretty much nailed it.
Yeah, he did. He did. So I just wanted to do that one before we move on to this that you sent. Let's go.
Okay, I'm including this so that people understand what's what's going on here. Okay, first of all, you notice the big red circle kind of in the middle there. That's the gyra. That's the gyra of the Atlantic Ocean. And the GS that you see over there at the 9 o'clock position, left side there, that's the Gulf Stream, of course. The Gulf Stream, when it goes over the top there towards Africa. That's the North Atlantic Current. It then comes south and then returns as an equatorial current to form that loop. The red arrow that you see coming from the South Atlantic, that's part of the return flow of the conveyor belt. Now, when you look at the top, you see there's a branch that heads up towards Greenland and higher latitudes. That's the North Atlantic Drift.
Yep.
It is that port that pinches off the gyro. It is that portion that our people are concerned about. It is that portion that is slowing down. This is slowing down. It's slowing down, so the deep water formation and the rate of sinking are
Mm-hmm.
slowing down.
Mm-hmm.
Now, if AMOC were to collapse, or as I'm going to say, full stop, that North Atlantic drift will not be there. There will not be any flow going to the North Atlantic.
Mm-hmm.
Okay? So as it goes currently, as it goes up to the high latitude, it's warm water. It's also very salty water. So it cools down. It cools down. This is historically, it cools down and it sinks.
Yeah.
As it sinks, that's what the DWF is, deep water formation, that I put up there.
Yep.
It sinks, and then you get the blue arrow now. That's the North Atlantic deep water. That's the return flow. It sinks to about 2,000 meters or so deep in the ocean, and then flows back south,
Mm-hmm.
and it goes through the two
Mm-hmm.
Atlantic Oceans. Eventually, through friction with those other water masses, friction imparts heat, which reduces the density. It starts to rise. It upwells, bringing in nutrients. It upwells in a region called the Antarctic Divergence Zone. That brings in nutrients. That fuels the Southern Ocean, the ecosystem there.
Yeah.
Brings in nutrients for the phytos to do their thing. And then you get the zooplanktons, the krill, the ballenes, etc., etc. My concern is that the deep water, if the NADW, North Atlantic Deep Water, if that slows or stops, you're going to effectively kill that Southern Ocean ecosystem. That's what you're talking
On
about,
a
a major
way.
ramification. That's it right there.
Major, major, and in Iceland, as they were talking, as I was watching the Arctic Council, you know, they know if this gets worse, it will ruin their everything, their way of
Yeah.
life, their economy, fishing, everything, everything.
But as I say, it's it's like with the blue ocean event. It's not so much the BOE itself; it's the fact of losing the sea ice. The
Yeah.
fact that AMOC is slowing. It's still going. It's for now. It's still making deep water, and there's
Mm-hmm.
still NADW flowing south.
Mm-hmm.
For the moment, it's reduced, but it's the slowdown, not the when it stops,
Right. Right.
then we're WASF.
Uh,
No, it's happening now.
Yeah, but
You
it's still not something that's happening, tomorrow. Okay, it's not. It's not. Nobody's
Yeah,
saying it, but it's happening again
it's
faster than
it's like
previously expected.
it's like a lot of population biologists say that when temperature hits 4C, that'll be goes extinct. Well, it's not like, okay, 3.99, 3.999. Humans are still
Okay.
here. Ooh, 4, boom, we're all
Oh
dead.
no!
You know,
Boom!
it, it works its way to that
Oh
level.
jeez.
So as AMOC
Uh,
slowdown becomes more and more pronounced, it's working its way to severe
right.
consequences. And
Right.
one of those severe consequences is that you then, instead of having this nice heat distribution mechanism for the
Yeah.
planet, when you cool down the lower latitudes and warm up the higher latitudes, you're now going to start getting severe temperature gradients where lower latitudes are going to really start warming up, and higher latitudes they're really going to start cooling
Phew.
down.
Scary. All
At least on
right.
the Atlantic side. The other thing you have to look at, studies have shown that, or at least simulations, that as everything is changing around, as the North Atlantic drift starts slowing down, the North Atlantic current that you see there, that actually shifts several degrees northward. Where it swings across, it
Hmm.
actually shifts several degrees north latitude, which will then bring warming conditions to like southern and central Europe.
Yes,
That's the some. That's the, some of the you know. But of course, with all of this, you're bringing changes in precipitation patterns as well.
as well. We ready to move on?
Sure.
Okay, here we go with the heat content.
Here we go. Indeed. Now,
Indeed.
why do I put this in here? If you look now, of course, the baseline is based on 1981 to 2010, so that 30-year period,
Hmm.
and then they look at the ocean heat content in the upper 2,000 meters. So basically, you know, the annual mean, okay, that's based on the 81 to 2010 time period, and then we have the ocean heat content anomaly, okay, anomaly in zettajoules. Okay, it's
And
a
we
lot
all
higher.
know we learned zettajoules from you. That's the heat measurement in the oceans.
Z- Zetta is 10 to the 21. So for example, if you see a value of 200, that's really 2 times 10 to the 23 joules. So it's a wee bit of energy,
Yes, a
but
wee bit. Yes.
but okay, this is a lot higher since then. This graph's like a couple of years old. It's a lot higher since then. We're in excess of 460 zettajoules on
Oh,
the top.
wow.
And this
Wow.
is the upper 2,000 meters. 68% of that heat is concentrated in the upper 5 to 700
Right.
meters
All the way up top.
because as the water heats up, deep water sinking,
Yep.
thermohaline flows slow down. So
Yep.
that's another mechanism by which, and to go back to what's going on with all that Greenland melt, okay, that's reducing the salinity. So even though the Gulf Stream, the North Atlantic drift gives off its heat, in the past it cooled down, it became very cold, salty water, sank. Well, now it's cold water, but we have fresh water lens on the surface, not as dense, doesn't sink. This is why people are concerned. But for reasons we discussed before, it may be a good idea to review those again. There might be other factors involved that could uh, forestall a total shutdown of AMOC. But anyway,
Okay.
why do I pull this up here? If you notice, starting about the mid 1990s or so,
Hmm.
you see that the heat content goes from blue to red.
Yeah. Hmm.
I make the argument that the planet Earth, planetary system as a whole, it went past the tipping point there,
Right
where we're
then.
now on an irreversible course of climate chaos. So
Seems
that
so.
we get the exponential increase in warming, we get the exponential increase in permafrost thawing, releasing more methane, adding to warming. We get the increase in extreme weather events and swings, and we get the increase, changes in precipitation. We get the precipitation bombs and so on and so forth, and get the increased melting of ice.
Everything
This
started.
this is now it's now on a runaway system here, and I make the argument that that happened in the mid '90s.
Well, it makes sense because we were polluting badly. I mean, yes, we made changes in the world. We took lead out of gasoline. We did a lot of things to make headway, but it certainly doesn't seem like the headway is enough, does it? No.
No, and
No.
don't forget you toss in pipeline warming, lag effects, yada yada. It's
Oh, all
it's
the
locked in.
methane news that's been this week, of course. The
Yeah, it's
methane coming from all the different places, and it's not just methane from uh, fossil fuels. It's methane uh, from farming, from everything. Permafrost thaw. There's
you have
methane. Yeah.
you have biogenic and you have thermogenic sources of
Mm-hmm.
methane. Look at going on, for example, in the East Siberian shelf. You get these methane burps where something happens to the substrate there, and the trapped methane is suddenly released.
Yeah, right. Chip's asking, do we have any good news? Uh, it's not easy, Chimp. I mean, it really isn't. We're here to give you science news, and it's not, I don't know what to tell you, but I thought I would bring that up. Next one. What do you say?
The World Series started tonight, anyway. But
Okay. All right. So there's good news for sports like lovers.
for any Dodger and Yankee fans, but
Okay.
anyway, but
All right.
in all seriousness, and the reason why I thinking back to the previous slide where I said, the Earth went past the tipping point because the Earth is an ocean planet. It really should be called Oceanus. This is several years old. There hasn't been any updates on it, but this is the heat blob, the heat content in the Pacific Ocean,
Yeah.
the
The
North Pacific
blob.
Ocean, which is a huge area of the planet.
Mm-hmm.
The Pacific Ocean. If you take the photo of planet Earth just looking at the Pacific, you
Mm-hmm.
would think it's a water planet, which Earth is. All this
Oh,
heat in
yeah.
there, this heat is going to keep warming the planet because as the water stratify, it can't sink. If it can't sink, physics informs us, the thermodynamics informs us that this heat is going to go in one of several directions, sideways or up. Sideways, it goes to the higher latitudes where it
Yep.
melts the sea ice, melts any cantilevered land ice. Up, oh, that means it diffuses to the atmosphere, which means it also increases the sea surface temperature. Now, this is for the Pacific. There's a huge amount of energy there. You can see the scaling there, and you can see how deep it goes down to 300 meters, 400 meters, and so forth. And there's I didn't send it to you but there are recent similar figures for the Atlantic Ocean, and
Mm-hmm.
then in the Mediterranean. Remember, the
Mm-hmm.
Mediterranean water ends up in the Arctic Ocean because it becomes the North Atlantic intermediate water. It ends up there, melting the ice there, blah blah blah. So, and that could undercut the deep water formation as well. But
Mm.
again, there's a lot more of this in the Pacific, but you have basically a huge heat battery, heat capacitor, however you want to use it, that's a big full potential and is ready and it is discharging.
Phew. That's pretty hairy. It's discharging. Yes, I have been watching The Blob for a while. The blobs. Jennifer and I, we used to talk about these blobs all the time on our shows. She'll be back. She's just, she's on her hiatus from all of this, from the doomosphere, so to speak. Okay, so do we want to move on?
Sure.
All right, we have one last one. And it's not the easiest to see, but Jim's going to explain it. And it's all of
So
the different C's.
so what this does is it shows the changes in the heat content for different regions of the planet. And if you look for and they show the different boxes show the different regions. So, for example, let me peer in a bit here. If you look, there's the black box, and then
Mm-hmm.
there's a little arrow showing the Northwest Pacific, and then there's one for the
Go
Southern
figure.
Ocean, and given in yellow. And they have the Indian Ocean, and then they have the let's see, the blue is the North Pacific, then you have the North Atlantic given in purple, the Mediterranean Sea, and the
Mm-hmm.
tropical Atlantic. The
Okay.
only one that really does not show too great of a change in ocean heat content is the Northwest Pacific, but all the others we see major increase in heat content contained in those basins, those bodies of water. Now, the
Right.
gray that you see there, those are the 95% confidence interval, you
Mm-hmm.
will note that over time, the gray areas shrink. And that's very simple. Our technology has improved. The accuracy in our measurements have improved, so
Yeah.
that there's less uncertainty. Excuse me, less
Mm-hmm.
uncertainty in the measurement. So we're better able to refine our measurement and get more and better and more accurate measurement. But we see all this heat there. So again, okay, all this heat content, the the northern hemisphere is not going to cool down collectively.
Jim, I have a
The North
question.
Atlantic region
Oh,
will, but not
all
the
right.
whole hemisphere as it done in the past.
But you said about the Pacific Northwest, am I right? That there's not showing the concentration of heat. Why are they having atmospheric rivers and those kinds of issues there?
Because there are changes to the jet streams, there are changes
Okay.
to the atmospheric cells, which there are changes in the temperature gradient and in
Hmm.
thus in the precipitation gradient.
So it's not always the heat in the ocean. There's all the other factors
It's
that
a couple
come
it's a
together.
couple it's a couple system, but the oceans are driving what goes on in the atmosphere. But if you
Oh,
look at even
absolutely.
Northwest Pacific there, there's a
Yeah.
lot of variation there. So
Yeah.
it's just it just could be that,
Yeah, you
that's
see
your
it.
best
Yeah.
curvilinear function,
Hmm.
but I'd be willing to bet you that the R square is not that great. So, the
Right.
which is how well it fits the data. There's just a lot of variation. You look at the other regions there, and the variation is less, so it's a better fit. And the typical variation are seasonal variations.
Okay.
But it's all this heat that it's the rest of the planet is going to keep warming. And
It's
and there's still going to be
hot,
changes.
baby.
You're going to see changes in the jet stream. You're going to see changes in precipitation. And overall, the planet's warming. It's just that the North Atlantic is in for some challenging time. Well, we all are, but the North Atlantic is the cool spot on the planet, or the cooling spot on the planet.
I have a question. Where he lightning rod? Hello, sweetheart. I love that graphics. Question: where are they from? What's the source?
I did a video called "Ocean Heat Content."
Okay,
That's where it's from.
okay, and we'll be. I'll be showing the page.
But
All right.
it's the work of Chang et al. He
Okay.
he's a well-known oceanographer,
Hmm.
and he does a lot of the yeoman work on this.
All right. Great. Great. Well, I think what we're going to do now is we're going to move on to Ramsdorf. We're going to play his video. So hang on, and then we will talk about what we hear there.
The consequences once the AMOC is collapsed in a globally warmed world look something like this. In the top panel, you see then the annual mean surface temperature changes and, the planet warms, the northern Atlantic region cools. The exact location of that cold patch depends, of course, on how much warming there is compared to the AMOC collapse, how far along are we already with warming, how early does the AMOC collapse, and so on. But the bottom panel shows changes in rainfall patterns, and we also know those from paleoclimate. There have been drastic changes every time the AMOC collapsed during the last ice age along the tropics, because the tropical rainfall belts, they shift south when the northern hemisphere cools and the southern hemisphere warms. But of course, here in this part of the world, we are mostly concerned about this. And I sometimes get asked by journalists, well, isn't that great, say, in northern Germany, the two effects just compensate? But that's an illusion, of course, because that's only in annual mean. But we don't have ever annual mean conditions out there. We have weather, and it varies depending on whether we have cold air from the north or warm air from the south. And the contrast will be much greater. And these contrasts drive storms, they drive extreme events. So if you have southern Europe warming and northern Europe cooling, that's really bad news for extreme events. And there are also other consequences for CO2 uptake by the ocean, which normally with the AMOC gets drawn down into the deep sea by the deep water formation. The oxygen supply for the deep sea comes with this deep water formation. There are big sea level changes in response to an AMOC collapse. So there are many very serious problems. And to finish off, I want to point to that big report on global tipping points published last year by more than 200 researchers from over 90 organizations in 26 countries, which concluded that harmful tipping points in the natural world pose some of the gravest threats faced by humanity. Their triggering will severely damage our planet's life support systems and threaten the stability of our society. So my conclusions are the AMOC is weakening. I think very strong evidence for that. The AMOC has a tipping point, well understood since the 1960s and confirmed again and again with more and more complex models. But the billion-dollar question is, how close are we to this tipping point, and will we maybe push it over the edge already in the next few decades? And recent studies have really given certainly me the impression that this risk is much greater than we thought just 5 years ago.
And that is very interesting because even our shows over the past few years, we were not convinced that this was something that was just going to happen tomorrow. And of course, it still is not. You know, he was just giving a scenario, like I think a worst case scenario. But because the research has come out to be a little bit different than what was expected, got to prepare the world for this. In how many decades? You know, I don't know, Jim. What do you think on the scale of how messed up things are? Where is AMOC?
Well, AMOC is important. As I said, I want to reiterate, it is definitely slowing down, and that is going to cause problems. But, I just did 4 recent videos that looked at the mechanisms by which AMOC comes to a complete stop. And what some of the researchers concluded was that the melting of Greenland, as much as it is, and it's melting a lot, is insufficient to bring AMOC to a complete stop. Now, it does introduce a freshwater lens.
Yeah.
So yes, you do dilute the surface salinity. So yes, the sinking slows down, but because it's liquid, it has a chance to be mixed, to get entrained, and due to the physics of the region, a lot of that entrainment gets concentrated on the western side of the Atlantic or off the eastern seaboard of North America. So you get a sea level rise on that side, but their contention is that it is insufficient to bring AMOC to a stop. What they and other researchers say are the mechanisms to bring AMOC to a stop, and Wally basically indicated this in his work, is that you need a major flush of fresh
Oh,
water.
really? A major
Yeah.
flush.
Yeah,
That's the first one.
that was the cue. Okay, good. But you need a major input of a huge amount of fresh water all at once. And what some of the researchers showed is that looking at the Heinrich events, the Heinrich events are when we have massive amounts of very, very large, containing large volumes of ice that break off and go to lower latitudes and melt all at once in situ. And when that happens, that's the shock to the system that AMOC just
Right.
comes to a screeching halt. Within years, whatever, that kind of stuff. Or was a lake Agassiz some 10,000 years ago, something like that. But it was a buildup of this huge freshwater situation in the Canadian Shield, and the dam literally busted, and all this fresh water just went right, just flushed right out into the North Atlantic and brought AMOC to a stop.
It went. Yeah. Okay. Not making
So,
it funny.
so those, so the melting alone, according to this new research and new modeling, melting alone is insufficient to stop AMOC. Slow it down? Yeah, sure,
Ooh,
obviously. You know, slow it down significantly? Again, yes, but again, define significant slowdown. What concerns me today is what's going on in the Arctic Ocean. What's
right.
going on in the Arctic Ocean is in the Arctic Ocean, first we have the Beaufort Gyre. Beaufort Gyre is an anticyclonic gyre, meaning it flows clockwise.
All right.
Clockwise gyres in the northern hemisphere have a
Hmm.
convergence zone in the middle. So there's a lot more precipitation happening in the Arctic. And we have riverine inputs, and we have melting sea ice and more precipitation from the atmosphere. So we have this fresh water building up in the middle of the Beaufort Gyre. Now, if you look at the Arctic dipole uh, helps steer whether sea ice stays within the Arctic Ocean or gets moved pushed out through Fram into the North Atlantic. Well, that also controls what happens to the freshwater. And thanks to the work of my friend Igor Polyakov, he's shown that the Arctic dipole impacts the halocline of the Arctic
Right.
Ocean, which is important information. But if conditions are just right, where the Arctic dipole and something happens to this Beaufort gyre, you can conceivably take this freshwater
Oh,
buildup, move it right into the North Atlantic, and you again have this big, massive input, and that could be the
yes.
shock to the
Yeah.
AMOC system.
I
But now, don't forget, the deep water formation sequesters heat and CO2.
mm-hmm.
Well, you're not going to
Yes.
sequester that. So the reason why the
Oh.
air that region stays cool is because of the cold sea surface temperature.
Oh.
But you're still going to have the buildup of the CO2 now stays in the atmosphere. And of
Yep.
course, you got to look at what the AO and the Arctic Oscillation, North Atlantic Oscillation are doing. But you're not pulling down, you're not sequestering all this material. You're not what we call ventilating the ocean. You're not getting a
Okay.
turnover. So this leads to stagnation, leads to stratification that shuts down primary productivity. So that's another bad thing about AMOC slowing and maybe fully stopping is what it does. In fact, just the ocean heat content in general, it's stratifying the ocean, which is impacting vertical movement, which means mixing and nutrients and
Wow.
so on, and that will impact primary productivity or NPP, net primary productivity.
What do you see the etiology of, I mean, not the etiology, the time frame, or I mean, is it all now just a flow of happening?
I have I have no way of assessing that. I
Right.
mean, these things. I mean, we know things are increasing exponentially, or at least polynomically, but
Okay.
it's nothing to stop it from being in spurts.
Okay.
You get a jerk to the system. I mean, it's like you have something accelerating, then you have a sudden change in acceleration. The third derivative. You know what the third derivative is called?
I'm gonna learn.
It's called the jerk.
The jerk.
Seriously,
I
you
wish
have
I had a sound effect for that.
you, you have the position function. You take the
Okay.
derivative of the position function, you get the velocity function.
Do I have a
So velocity is just a change in position per time. So a change in velocity per time is acceleration. Well, a change in acceleration per time is the jerk,
the jerk?
third
Oh,
derivative.
third derivative. Okay, well, pretty interesting. All right. So, I think it's time to mosey on to the discussion we wanted to have about, because we are almost an hour, we wanted to have about the lack of being able to collaborate on this so important issue of collaborating with Russian scientists. It has all but stopped.
It has. Um,
And yeah.
yeah, I actually have a video all ready to go, but I've been debating about, and I may just only post it to YouTube
Yeah, just put it on YouTube and I'll share it everywhere else.
because um, there are some people who have well, the algorithms that have been deplatformed on Patreon for posting stuff about Russia.
And this is science. This is ridiculous. So put it
But
on YouTube and I'll share it all over Facebook and see what happens. Screw that. This is
so,
important work. We're
but
missing.
it's basically that um, between Patreon, buy me a coffee, there might be some issues of the algorithms picking up. Oh, it's Russia, so deplatform the creator or whatever.
Oh, screw
So
that. Don't
yeah,
do it. Don't do
I
it.
may just put it only on.
YouTube. But don't even put the name. Don't even use the title and then get into it. You don't have to definitely tip them all off, which is my problem. I tip them off right beginning of my stupid thumbnails, and they always demonetize my stuff. But I think it's very serious, and I did want to show people the Barents Observer really quick, because if you do, hang on, if you want to see information, and then I'm going to show you Jim's page on that area and what's happening. The Barents Observer is right there. They're right by Russia in Norway, and Jennifer and I had interviewed Thomas Nielsen, the editor, and you can learn everything about that area from the Barents Observer. So I'll have this link in the show notes, and they cover everything. So I just wanted to show you that, and really quickly, because I want to show you Jim's YouTube, because there's so much good content on here, and I'll go into the videos. As air temperature increases, Arctic precip rates will double. Arctic sea ice leads to stronger El Ninos. I mean, 2023 was the hottest summer, and you had is AMOC collapse imminent. Here's your 25-minute video right here. So there's a lot of good stuff.
And the next one, there were all the little forams there. That's another related to AMOC.
Uh-huh. Okay. So everybody, really, there's so much stuff, and you can learn so much because, Jim is our science teacher. That's who he is. He's our science teacher. And that's what you're good at.
And going back to the loss of the collaboration. I mean, this has created major holes in our data, major holes in our
Absolutely.
understanding of what the processes going on. Uh, I don't hear from Igor and Natalia anymore. Igor Smelatov and Natalia Shakova. I don't hear from them anymore because
No.
for various reasons they had to return to Russia. For career moves and funding and all that kind of stuff there.
Yeah, it's
But
sad.
now the country's been closed off, that no emails in or out are allowed.
It's awful. And I think it's a horrible loss, because Russian scientists are some of the best, and it's not their fault, and they are probably very upset at losing the collaboration with the rest of the world, or at least the Western world. I don't know if they're able to collaborate with any of the BRICS people. I don't know any of that, but it's just sad. It is. I hope that passes.
I mean, I'm glad I was able to convince Igor to stick around. Igor Polyakov, the other Igor, as we jokingly say.
Well, maybe you could interview him sometime. Would that
Yeah,
be a
I've been thinking about
possibility? We
he's
could do
very
it
shy.
here. Oh, I would say we could do it here and I'll run it for you, but that would be up to you. That would be up to you. All right, so I think we covered in an hour quite a bit. I think we'll do a few questions and comments. The first
But
thing
there
what? Go ahead.
There will be changes to precipitation pattern, as you know in that clip from Ramstorff. There was that little graphic of showing the changes in precipitation.
Yes.
We noticed that overall it looked like the northern hemisphere is getting drier. Well, if it's going to cool down, cooler air holds less moisture. But it's also coming down to changes in the in the atmospheric cell, Hadley, Farrell,
Right.
whatever,
The Hadley
changes in the
cells.
jet stream, changes in the gradient, so that, and then overall shifts in the precipitation belts. Like we mentioned earlier, the ITCZ, you know, that gets moved about. So you're going to see changes in precipitation. You're going to see the precipitation bombs. Wet areas get wetter, dry areas get drier. You're going to see all these different things here. And don't forget, you then have changes in evaporation patterns from the ocean. Because
Hmm.
typically, the oceans, from the tropics, the oceans evaporate. You get the moisture in the clouds. The jet stream moves those systems around. It precipitates somewhere else. You know, but what's going to happen is that you're going to probably start getting more precipitation in the lower Atlantic Ocean latitudes, which could dilute the surface salinity there. That that's a potential possibility. There's a lot of there are modelings are basically projecting all sorts of directions these things can go. It's difficult to know exactly, but what we can do is our best guesstimates.
Yes. All right. Well, it's you guys out in the first. I want to do the three and thank you, Kim, very much. Jim, can you please explain why the AMOC slowdown will lead to flooding along the eastern seaboard of America?
If you look in the North Atlantic, there is a little gyra up there. That gyra is cyclonic, which means it's a counterclockwise flow. So the counterclockwise flow in the northern hemisphere have a divergent zone in the middle, which means an upwelling. So what's going to happen is it's going to take that fresh water that gets introduced, and because it's flowing counterclockwise, it's going to push it
Okay.
towards the eastern seaboard. It pushes it west. So it pushes it up, and you get higher sea level rise there. Similar thing
Mm,
with there's a thing called in gyres, there's a thing called western intensification of the gyres. So that when you
mm,
look, for example, the Gulf Stream, it
mm-hmm.
flows a lot faster. It's also a lot narrower and it's deeper. And then by the time, and that's because it's balancing vorticity and Coriolis and the fact that the Earth is spinning in that direction. So by the time you get over to the eastern side off Africa, it slows down considerably, but it's also a lot wider and shallower. And then
Ah,
as it moves south and then starts moving back to the west, it starts being
okay.
built up to get the intensification again. It was Henry Stommel who mathematically demonstrated this in a paper that goes back to, 67 years ago, 1957.
Really? No
Yeah.
kidding. Well, I might have to find that link. Well, okay. And thank you, Charlie. Thank you, Chaz. And Dwayne, I know it's not much, but I feel so proud to have voted this past weekend. We are so fucked, but at least we can collapse with some dignity. Voted Kamala. Okay, collapse with some dignity. We are very dignified here. This is the channel of dignity. Yes. Okay. Love you, Dwayne, because you just got your PhD. We're all very, very proud of you. Okay. Wendy, the AMOC has momentum in terms of mass times velocity, but with less sinking water near the Arctic Circle, friction decreases the momentum of the AMOC. That was a Wendy comment. And Oliver has a question. Oliver is way up past his bedtime in the UK. I don't know when you sleep, sweetheart. I really don't. If huge bulk release of fresh water, be it melt or lake gyre trapped, what is the best approach to managing the slowdown so that it's a managed release, if that's possible? Mm.
Yeah, I don't know if I can answer that.
All right. Well, you know what? Think about it, and maybe you can do a video on it.
I mean, it's we're talking scales here that is just huge.
Okay.
I mean, the yeah, the Arctic Ocean is a small body of water, but it's a dynamic body of water. But it's still
Hmm.
a big thing to try and control.
Okay. Well, thank you, Oliver. You're very sweet. Um, will there be detrimental consequences? Well, to everything. So I
Oh
don't
yeah,
remember where we were talking, but I mean, everything we're talking about has some detrimental consequence to some ecosystem on the planet.
yeah. I mean, everything that's going on, whether you're looking at AMOC or temperature increases, CO2 levels, it's all, it ain't going to be good. None of
Mm.
it. I
Um,
mean, and you get, for example, you get these idiot. Well, CO2 means plant food. No, no, you idiot.
Oh, are
Shut
you
up,
give are you giving me
shut up,
my
sit down.
my short? Because you know I did a short. Did you see the short I did with you saying about Marjorie Taylor Greene and the CO2?
I,
Oh, I did.
I,
It
I
was
did
funny.
not actually.
Oh, a
I
lot
did
of
not.
people have. It was cute. It
But
was
you know,
cute.
it's like everything else. You know, plant plants like every other organism have preferred temperature ranges, and most of the crops we grow for human consumption are C3 plants, which means it's the physiology, but they prefer temperatures less than 86 degrees Fahrenheit or less. Anything above it, well, they lose water and they
Right.
wilt and die. There are some C4 crops that we utilize, for example, corn,
Yeah.
but even they are stressed out. So the
Mm,
warmer temperatures is not good for plants because they have the issue of, well, I need to open my stomata, which is the openings on the leaves, to have gas exchange. But if I do that, I also lose water, transpiration. So I guess we've got to conserve the water. So we shut down. We don't do the gas exchange, but we still end up respiring. So now that the as the temperature increases, the rate of
respiring.
respiration for the plant exceeds the rate of photosynthesis,
Mm,
which is not good. Which
okay.
means this is why we're seeing a reduction in crop yields
Oh
and
yeah.
increased crop failures.
Okay, Gary. Even if the AMOC slows down quite a lot, it will that not bring serious consequences? Well, yeah, we
Yeah,
just
of
saw
course.
that.
Yeah,
Yeah.
yeah.
Okay, that might have been
Uh,
the
My,
question.
the point I'm trying to make is, just like with sea surface temperature, there is no accepted definition of what constitutes sea surface temperature. Some say it's just the skin right
Right.
there at the air sea interface. Some
Right. How
say
they
a
measure.
meter down, 2 meters down, 10 meters
Mhm.
down, what have you. We need just the accepted norm for surface air temperature is 2 meters above.
Yeah.
So
We've
surface temperature 2 meters down.
mm,
Let's let's
mm,
let's
mm.
let's uniform this. Let's have a standard. Well, we need to have what when they say AMOC collapse. What does that mean? If you're saying stop, then maybe should just say AMOC stoppage. Just use that word. Be blunt with it. If you're talking about tipping point, define tipping point. Or are we talking complete stoppage or severe slowdown? Well, then define severe slowdown. This needs to be defined.
Okay. All right. Uh I have to find Poppy's. Poppy had something and I lost it. Shoot, Poppy, I really wanted to tell you about my. I'm wearing pajamas. No, I don't think anybody gives a shit. She made a comment about my Winnie the Pooh. I'm wearing pajamas. Like, who cares? All right. I also want to say that Going South is hoping to have next week on his channel, Torstein Vidal, an interview with Paul Watson next week. Would be fantastic. Earth's biggest deep ecologist prisoner. If that happens, oh, we will be there with bells on and also share it everywhere. I'll play it on my channel too. I mean, this is going to be epic. So Torstein, that actually would be just amazing, amazing, epic. Okay, let's see. Oh, he had one more. We don't have 100th of the required meltwater for an AMOC collapse, Torstein.
Hmm.
But Torstein lives in Greenland and he studies all that too. So he's an interesting fellow. I've known Torstein since the beginning of this whole thing. Back in the day, we were going to actually do when we thought the Blue Ocean event would be like a thing, maybe I don't know, 7 years ago and 8 years ago, and we were gonna do the Blue Ocean event hour. Hey, you never know what's gonna happen. But yeah, we know each other a
Well, you remember
long time.
remember earlier this year there was the big hubbub about the reduction of aerosol is going to heat up the sea surface temperature and that's going to stop AMOC. Remember that?
Yeah,
That kind of
yeah,
fizzled
yeah.
because that's not a thing.
Wow. Oh, it's not a
Because
thing.
again, density of
Oh
ocean water, high latitude is
gosh.
determined by salinity, not temperature.
Yeah, I
And
always
also,
remember that. Whenever I think of the oceans, Jim, I think of salinity. Salinity. I should get it tattooed on me. Salinity.
but it was like it also, the Earth's a curved surface, so even if there's increased sunlight penetration, first of all, it attenuates rapidly in a water column. But because of the angle that it interfaces with the ocean, you're not going to get the full measure of it. So it doesn't impact that.
All right. Let's see. Let's see. Uh Tommyists, techno optimists think that space colonization will save the system. Well, I have a theory. I don't know if I've mentioned it on the channel, but Elon Musk, he is the alien. And he's just trying very hard to get back to Mars. That's my theory. He is the alien.
He can
He-
stay there.
he's trying to get back there. Okay. OG Skywatch, the Double Crisis Climate and Biodiversity, DLD Nature, is one of the best climate videos I've seen. Johan Rockstrom, another one, and is the Great Simplification, Nate Hagens. Thank you. Thank you. We certainly are a channel that likes to highlight every other channel that's fabulous out there because that's what we're about. You know, that's completely what we're about. All right. Da 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 da. I'm it's the salinity, stupid. Yeah, I hate to make, but I think about that all the time. Whenever I think about the oceans, I'm like, oh, Jim, drilled it into my head. It's the salinity. It's the salinity. All right. So by tomorrow, I wanted to tell you all on X, because we're still there, the Climate Crisis Club 100, all invited. They want to discuss the reindeer problem. Well, anyway, it's on every Saturday and it's on for hours. And I put my headset on and I don't go gardening or whatever. And I can listen to people from all over the world talk about everything under the sun that's climate, earth related. So I just wanted to give a shout out to Alex. Thank you for that. And I think we're pretty well getting there. Question: has EEI fizzled?
No, there's still studies and calculations being made showing that the EEI stands for Earth Energy Imbalance. It's still a thing. It's still increasing. Um, you do the breakdown from looking at the different. I mean, I have had disagreements with how it's calculated. Basically, the oceans tend not to be included in that, which is, I think, a mistake. But it's still being calculated, and annual reports being prepared, and so forth.
All
So
right.
it may not be as in the news, common news as often, but it's still being done.
Deborah, Musk should take Putin and Trump with him to Mars. I love you guys out there.
And,
You all have such fun. You're
and,
funny.
a few other characters.
Yeah, but we talk about the most serious stuff But if you don't have a sense of humor, honestly, I've been pretty miserable, not happy. And I suppose nobody is around the world with this nail biting election. Who knows what the hell's going to happen? But yeah. Yeah, chimp. 11 Hiroshima bombs per second. EAI, right? You've been doing your homework. Absolutely.
I
Okay.
want to, there was a comment earlier, I
Twitter.
forget who said it, that about divergence zones in the middle of gyres. You have to
Uh-huh.
look at the flow. If again, northern hemisphere, if the gyre rotates in a counterclockwise manner, or what's called cyclonic,
Mm-hmm.
you're going to have a divergence in the middle of it. If it flows
Thank you.
clockwise, which is anticyclonic, then you're going to have a convergence zone in the middle. Now, in the ocean, and same thing in the atmosphere, if you have a divergence, you're going to have an upwelling in the middle. If you
Okay.
have a convergence, you're going to have a downwelling. And it's reversed in the southern hemisphere. So just keep that in mind. That's why the most oceanic gyres, the middle of the ocean, are biological deserts, because you have a big convergence zone in the middle,
Ah.
downwelling, not much nutrients. So all the productivity in the oceans tend to be along the shelves, because you have Ekman pumping, Ekman upwelling, bringing in nutrients.
All right.
That's even the Southern Ocean, Antarctic divergence zone, upwelling, bringing nutrients. So this is why ocean stratification, the slowdown, even stoppage of North Atlantic deep water, is
Mm-hmm.
problematic,
Mm.
and so on.
Mm-mm-mm. All right. I want to mention that it is now 16 minutes over. But tonight, Letter Hack, if you want something completely different, progressive, political programming is on now. And you could go to the Letter Hack channel with Jaynar Jackson. And just wanted to give Matt a shout out, the best cartoonist on the planet. So that's that one. And I think we're pretty good, Jim. Is there anything else you wanted to say or cover before we say goodnight?
No, it's just that, as I said earlier, we need to better define these terms here. But AMOC is for sure slowing down. Does it come to a complete stop? Who knows? Probably with the current mechanisms taking place, I would say not likely. But
Uh,
how much does it slow down is unknown. You know, so
we have a very important question. I have to answer it. Oh no, Jim, you have to answer it. Is the flush of the day anticyclonic or cyclonic? Like a Dyson vacuum? Oh God. Now you know I'm tired. I'm getting tired. I want to
the
thank
di-
everybody.
the direction it swirls is a function of which way the water jets point in the toilet. It has nothing to do with Coriolis.
All right. Well, I want to thank you all and my moderators, Looney Tunes and Kim. Jean is away. I'm not sure when she's going to be back. Thank you. I love you all, moderators. Jim, thank you. Don't forget to, oh, and hello, Wanda. I want to say hello. Don't forget to please subscribe to Science Talk with Jim Massa and check his videos out. He does great videos and he's our natural science teacher. That's what he does. Good night, Jim. Good night, everyone. Thank you.
Good night, everyone.
Good night. And thank you all so much. We
Thanks for
love
stopping by.
you. We love you. We love you. We love you. We do. Love is one of those big things.